Hello, welcome to Robu. In this video, we are going to show you how to control a servo motor with RPI Pico. So if you are new to RPI Pico, the getting started video link is given in the description. So feel free to click on that link. So this is a SG90 servo motor. This servo motor has a torque of 2.5 kg per centimeter. That means it can lift a weight of 2.5 kg from a distance of 1 centimeter. It has a speed of 0.1 seconds per 60 degrees. That means from 0 to 60 degrees it takes only 0.1 seconds. So there are three wires in this: brown, red and orange. So I will connect these wires. So brown is the ground, red is 5 volts and orange is the control signal. So the control signal is a PWM signal. So what is a PWM? PWM stands for pulse width modulation. So the pulse width modulation signal, the output goes high and low, but the high time is varied, and that determines the angle of the servo motor. And the frequency of that PWM signal, that means each high and low cycle, after that it is repeated, high, low again, and the cycle goes on. So the time period is 20 milliseconds. According to this data sheet of this servo motor, the time period is 20 milliseconds, and 1 divided by 20 milliseconds will give us 50 Hertz. So you have to generate a 50 Hertz PWM signal to control this servo motor, and the on time should vary from 1 millisecond to 2 milliseconds. So now let's generate this 1 millisecond to 2 milliseconds PWM signal using RPI Pico. So now let's connect this RPI Pico. I have made the connections. The circuit diagram is given in the blog, the link is given in the description. So now let's connect this RPI Pico to our computer and let's write a code for it. I've opened Thorny IDE on my laptop. Let's start typing the code. So from machine is the library, import pin. We have to import pin and PWM. So these are the two class that we import, pin and PWM. Now we have to, on which pin we have connected the servo motor, we have to connect the pin, specify that. Now to write a code to mention the pin on which we have connected the servo motor. So right here, PWM is equal to PWM in the bracket pin 15. So on pin 15 we have connected the servo motor. Now we have to specify the frequency. So PWM dot frequency, we have to pass here 50. So this tells the microcontroller that we are generating a 50 Hertz PWM signal because we want the time period to be 20 milliseconds, right? And the on time we are varying. So we have set the PWM dot frequency 50. That means 50 Hertz is being generated. Now we will set the PWM duty cycle, which is 1 millisecond. So PWM dot duty is the function underscore U16. Inside this function we will pass a number. So 65535, which is 65535 is for a maximum, which is 20 millisecond. And 3, so I have calculated. So if 65535 is 20 millisecond, then 1 millisecond should be 3277. So this function PWM.duty underscore U16, this accepts a number. So 65535 is for 20 millisecond. So we have to pass 3277 for 1 millisecond on time. So I've typed here 3277. Now let's run the code. You can see that it's not 0 degrees. It's somewhat greater than 0 degrees. But now let's lower this number. So it's 3277, so 3277 is not the right number. So let's lower it. So I found it number is 1800, means 1800. So if I type 1800, you can see that it rests at 0 degrees. So 1800 is for 0 degrees. In similar way, I found for 180 degrees, and that's 8000. So if we pass 8000 in this function, you can see that the motor moves to 180 degrees. So between 1800 and 8000 we get angular rotation from 0 to 180 degrees. So now let's find for 1 degree, which is 8000 minus 1800, which gives us 6200. So 6200 if we divide by 180, we will get for 1 millisecond. We will get for 1 degree. So we will pass, and that number is 34.45. So for 1 degree, the number is 34.45. So let's write a function to pass any angular value in our code, and now we can write a function like this: define servo, and this function will accept the angle, and this angle will be according to one formula called so we now have to write a code for this angle. That formula is, so whatever angle that we are accepting in this servo function, that will get multiplied by 34.45. It will get passed into the function. So let's name it C. C is equal to 34.45, which is for 1 degree, multiplied by our angle, which we pass into this function. Okay, and this we convert to, and yes, we also have to add 1800 to it, right? Because it will start from 0 degrees. So have to write here plus 1800. So whatever angle, it's multiplied by 34.45, which is for 1 degree, plus 1800. Now we'll pass this C into this function pwm.duty underscore u16. We'll pass in this C value is our calculated angle. So yes, now let's pass some value into this servo function that we have created and run the code. So I will pass here 90 degrees inside the servo function, and now let's run the code. It's saying can't convert float to int. Okay, so we have to convert it into integer. Yes, now it will. So see, it moves to 90 degree. So if we pass 90 here, we get a 90 degree on this servo. If we pass here 180 degree and run this code, we get 180 degrees. If we pass here 45 degrees, we get 45. So in this way, the code is written, and you can also move between any two angles. You can run a for loop. So let's write a for loop which will go from 45 to 90. So I'll write for I in range (45). So yes, we will write here 45 to 90 plus 1, which is 91, and we will keep the step size of 5. So 5 degrees, it will go from 45 to 90 in steps of 5. So let's keep the step angle 2 degrees because, and write the code. Yes, now we will write here servo and pass the value I. Yes, we also have to give some delay between this. So we import time. So there should be delay between each step, right? So we will write here time dot sleep underscore milliseconds. So we will give a delay of 200 milliseconds. you can see that servo motor is moving from 45 to 90 in the steps of 2. And yes, to continuously go on, you have to write it in a while loop, right? Because the for loop is now ended. So let's put it in a while loop, while true. So it will go on forever. So it goes from 45 to 90 in the steps of 2 degrees. So this was the code. The code is given in the blog. The link is given in the description. So feel free to click on that link. So this was the project. If you found this project useful, give this video a like. Comment your favorite part in the comment section. Subscribe to this channel for more amazing content. Until then, stay tuned with Robu.in. Thank you.